Good morning, ladies and gentlemen. Welcome to Math 20-1, Chapter 5, Section 4, Solving Systems of Equations Graphically Notes. Now, these are notes. Please don't hand them in. So, briefly, graphing stuff. How many solutions are there here? Well, the line y plus x equals 2 is this line here. And x plus y equals 1 is this line here. Notice a parallel. How many solutions are there? None. We go here, this line is y is equal to minus 1/3 x plus 1, and it's also 3y equals minus x plus 3. How many solutions are there? Well, infinite. Stop that, people are watching. And finally, this line is y is equal to minus x plus 1. Oh, sorry, no, my bad. That's not minus x plus 1. That minus x means it's going down. This is y is equal to 2x plus 2. This line is going down, so the slope is negative. Y is equal to minus x plus 1. How many solutions do they have? One solution. They meet once. So, that's how you solve a systems of equations graphically. If they meet, one place there's one solution. If the same lines, they're infinite, and if there's no solutions, they don't meet at all. And note here, I expect you to be able to graph these equations. Yes, you would rearrange them to be y equals, so you can graph them on Mr. Graphing Calculator, because, yeah. Anyway, no comment. So, typical, if slightly nasty word question. Number of students attending a leadership conference depends on the price charged. It's determined that 20 students will attend the conference if each charged $75. For each $10 increase in price, one fewer student will attend. This situation is represented by the equation y equals, bracket, 75 plus 10x, close bracket, bracket, 20 minus x. The cost of running the conference is represented by the equation y equals 1,000 plus 75x. Graph using your graphing calculator. For each equation, identify what each value represents. All right. The equation of a linear function and the equation of a quadratic function form a linear quadratic equation. So, y equals, well, the first one, bracket 75 plus 10x, close bracket, bracket, oh, sorry, look at that, 75 plus 10x, close bracket, bracket, 20 minus x. Now that's a quadratic. And we have a linear equation, 1,000 plus 75x. Now, right off the bat, notice for the linear equation, my b value is 1,000. So my standard windows of minus 10 to 10 is not going to cut it. So actually, I should just go to my table of values. X is 1,500. Sorry, when x is 0, we get 1,500 and 1,000. 16, 17, 18, and it goes down. 20. Let's do windows 0 to 20. Now, x minimum 0. I'm sorry, I just brain fart there. Go back to my table. Yeah, so let's do window. Let's do, oh, you should about stop that. 1,500 and go up in groups of 100. Graph. Still not enough. 2,500. Graph. Here we go. So that's our graph like that. Now, we have to recreate this graph. That is, yes, you have to be able to draw it. And this is not supposed to be wrapped around like this. So briefly, this is my x value, which is number of students. So 1, 2, 3, 4, 5, 6, 7. All right, so 2, 4, 6, 8, 10, 14, 16, 18. Notice you don't have to label every tick mark. Now, we're also going to something like $2,000. So 1, 2, 3, 4, 5, 6, 7. Yeah, so make each one of these lines 200. 400, 600, 800, 1,000. 1,200, 14, 16, 18, 2,000. Now, you do that. Go to your table of values. And yes, second table, my bad. Okay. So, 15, 16, 50, 17, 10. 1500, 16, 50, 17, 10. 1000, 12, 14, 15, 16, 17, 10, be something like that. 1785, 1840, 1785, 1840, 1875, 1890, 90, and well, let's just do this, keep on going. Now, 1885, 1860, no, 1885, 1860, so you see it's starting to come down. 1815 and 1750. 1815 and 1750. 1665, 1560. So there we go, something like that. And a couple more. Okay. 1435, 1290, 1435, 14, 35, 1290, 1300. Yeah, something like that. So it goes down like that. And for my linear equation, I start at 1000 and 4 is 1300. 4 is 12, 1300. Don't need every data point because this should be a straight line. And a few more. 8 is 1600. And 12 is 1900. Where was I? 8 is 1600. Sorry, 6 is, and 8 is, there we go, something like that. Now, not the best drawing, but where do they intersect? Well, go back to the graph. Second, calculate intersect. Oh, you step back. People are watching. Yes, yes, yes. 10 and 1750. This is my intersect point. Okay. So, graph using graphing calculator. For each equation, identify what each variable represents. Well, oh, sorry. The x is number of students. I didn't label my axes. Poopy, poopy, poopy. Money. Or cost. All right, now. For each equation, identify what each variable represents. Now, solve the systems. The next bit goes solve the systems. What does the point of intersection represent? Well, we just said 10, 1750. That is break-even point. That is number of students. Cost equals income. Or break-even point. All right. So, here, be a little more specific. This blue line is cost, and this red line is income. If we look at this cutout, this intersection point here, we have profit, that is income is greater than cost. And here we have greater than this is loss, where income is is less than cost. Sorry. A little messy, but you get the idea. Okay. The coordinates are called solutions. Now, grab your graphing calculator, sketch these graphs. Now, I'll help you with the first couple. This one here, sorry, label them with their equations and then write the coordinates of the points of intersection. So I'll do the first one with you, then you can do the other two on your own. All right, so here, x minus y equals minus 5. You're all going to grab your graphing calculators and go minus y equals minus x minus 5, or y equals x plus 5. And yes, I subtracted an x from both sides, and then I multiplied everything here by minus 1. Okay, so y1 is x plus 5, and y2 is minus 2x squared plus 8. Now, here, as I said, the reason I'm doing this one with you is that immediately everyone will put the grid with the origin right in the middle, or the coordinate plane with the origin right in the middle. But if you look at your graph, you realize, no, that doesn't work so well. Because your first equation, y1 equals x plus 5, 1, 2, 3, 4, 5. Now, m is 1, which means it goes over 1, up 1, over 1, up 1, over 1, up 1, like that. Down 1. So this is y1, this is y. And the other equation is minus 2x squared plus 8. Now, 2, 4, 6. My b value, or my constant, sorry, my c value, my constant is 8. And what am I doing to my quadratic equation? Well, instead of going over 1 and up 1, I've got the minus, which means I go down, and I go down twice as much. So I go over 1 and down 2. Over 1 and down 2. I go over 2 and down 8. 2 squared is 4, times 2 is minus 8. 2, 4, 6. Sorry. Now, not the best drawing, but you get the idea. So, where did these two intersect? Well, you can clearly see here, 1, 6. So the points of intersection, I should be writing down here, 1, 6. Now the other one is a little hard to tell, but you grab Mr. Graphing Calculator, and you'll see that it is minus 1.5 and 3.5. Now, how do I know that? Because I drew it in my graphing calculator. X plus 5. And minus 2x squared minus 2x squared plus 8. Now, my windows are horrible. Minus 10 to 10 groups of 1. Minus 10 to 10 in groups of 1 graph. And there we go. Second calculate, actually no, table of values. And there we go. When x is 1, y, both y's are 6. Now, and yeah, they intersect somewhere around minus 1.5, but anyway. So second, graph. Second, calculate, intersect. Now we want to go to the left because we have two intersects here. Mr. Calculator's going this one, are you sure this one? And that's the second graph, because we can do 10 graphs. And they're going, yes, guessing, minus 1.5 and 3.5. That's where the numbers came from. Now, I admit I did that a little quickly, but it's graphing, and you guys show me you can do that. So I'm going to pause the recording. We'll come back and compare the answers for the next two and see how it goes, okay? So pause the recording, graph them, and see what we get. Okay, welcome back. Now, when I drew my graphs, the first one I did was the quadratic. Bracket x minus 2, close bracket squared plus 4. My vertex is at 2 and 4. My a value is 1, so it means I go over 1, up 1, over 2, up 4, and I got my graph that I drew in red here. The second equation, y equals, 2x plus y equals 7. I subtracted 2x from both sides and got y2 minus 2x plus 7. I got that graph. And notice they touch in one spot and one spot only. 1 and 5. Don't believe me? Go to your graphing calculator and check. You see there's one intersection point. Okay? Now, let's pause the recording. We'll come back and compare the answers for the third. Okay, guys. When I did the third set of equations, y1 equals minus 1.5x squared plus 6, I got the blue graph. Vertex is 0, 6 and going down. The second equation, x minus 3y equals minus 21, or minus 3y equals minus x minus 21, or divided by minus 3, I got y2 equals 1/3 x plus 7. You draw that, you realize, wow, they're close, but there's no intersection points. There's no intersection, no solution. So, different numbers. So, question 3. Use the graphs in part 2 to identify the different numbers of solutions that a linear quadratic system may have. 2 solutions, 1 solution, or 0, depending on how many times they touch. All right? Now, some practice for you guys. Graph these quadratic functions on the same screen. Sketch the graphs. The equations of 2 quadratic functions form a quadratic system of equations. So, y1 is 2x squared minus 6, and y2 is minus 0.5x squared plus 4. Now, pause the recording, grab your graphing calculator, graph these, and then draw them on the grid, on the coordinate plane here. Come back, and we'll check each other, and we'll check our work, okay? So, pause the recording. Let's go. Okay, when I drew my graphs, I got that. The green one, y1, 2x squared minus 6. Notice I start at 0 minus 6, and I go over 1 up twice as much, 2. Over 2 up 4 times 2 or 8. I get that. And, excuse me, and y2 is minus 1/2 x squared plus 4. I get the blue graph. Where do they intersect? Minus 2 and 2, and plus 2 and 2. 2 intersection points right here and here. Now, how could you change one of the graphs in this equation so the graphs do not intersect? Well, so how could you change one of the graphs? Well, remember, the easiest way to draw the graph, we could change an A, a P, or a Q so that one of the graphs gets skinnier or changes direction. If they both opened up and the blue one was much skinnier, they wouldn't intersect. If we change the p-value on one of them, like to plus 50 or something, then one graph is going up and far away, and the other graph is far to the right or left and going down. But the easiest way is to change Q. By far the easiest. Change Q value. So if we went y is equal to 2x squared plus 5, instead of 2x squared minus 6, it's above and doesn't open, and it opens up. That is, our green graph would be up here, and our other graph would be down here, and they don't intersect. That's the easiest way to change it. Now, how could you change one of the graphs and its equation so the graphs intersect at exactly one point? Well, it's easy. Same Q value. So make them both y equals, I don't know, 2x squared plus 113, and y2 is minus 0.5 x squared plus 113. As long as the two Q values are the same. Actually, no, I can see you guys trying to graph that. So let's change them both to 3. All right. Now you can go ahead and graph it easily. You don't have to change your windows. And you'll see one opens up, one opens down, but at the same vertex. One point of intersection. All right? Now, going on again, sketch the graphs, use a graphing calculator, label the equations, write the coordinates of the points of the intersection. And notice we're dealing with two quadratic equations here. And once again, when you draw them, don't please. Didn't stress this as much as I should have. So many of you go right like that. Well, you can do that, but if you think about it, this first one starts 1, 2, 3, 4, 5, and goes up. The second one starts at 5, 6, 1, 2, 3, 4. Sorry, that's 4, not 5. My apologies. All right, be like that. 1, 2, 3, 4, 5, and opens up. This one, the second one's at 7 and opens down, so it doesn't work very well. Draw it on your graphing calculator, and then you realize, oh, once you do that, all right, don't work, you go ahead. Put your x-axis down here, and then you clearly see the first equation, 1, 2, 3, 4, 5, over 1 up 1, over 2 up 4, over 3 up 9, doesn't show, so that is y1. The second one, I'm going to call y2. Starts at x at q-value of 7, 1, 2, 3, 4, 5, 6, 7, and goes down, over 1, down 1, over 1, down 1, over 2, down 4, over 3, down 9, okay. So there we go. That's not even close. Let's go to that point there, so there we go. Now I did that off the top of my head because I've been doing this a long time, and I told you memorize the table of values for the basic quadratic. 0, 0, 1, 1, 2, 4, 3, 9. All right? So here the coordinates of the intersection are 1 and 6 and minus 1 and 6. So there's two coordinates of 2 points of intersection. Now, I'm going to be quiet. I want you guys to graph B, compare the answers, and come back. And then we'll do C and D. All right? So go do B. Okay, guys. When I graph this second set of equations, y1 is bracket minus x minus 3, close bracket squared, and y2 is minus 3x squared plus 6x minus 9. I got that. Notice I didn't put the coordinate plane right in the middle, and more importantly, there's no intercepts. All right? If you got something different, go back and check your equation graphing calculator. All right, now, once again, let's pause, and we'll do this. I'll do C and D, and we'll come back and compare answers. Okay, so for the third one, when I graphed y1 is x squared, and y2 is minus bracket x minus 2, close bracket squared plus 2, I got that. One intersection point, table of values, and then I checked with intersections, and there's only one at the coordinates are 1, 1. Now, finally, once again, let's pause the recording and do D. And D is, surprise, surprise, infinite number of solutions because they're the same graphs. Just written out differently to confuse you, but Mr. Graphing Calculator shows you that. And remember, check on your table of values just in case your windows are off. And you'll see 1x, both y values are the same. Now, use the graphs in part 5 to identify the different number of solutions, 2, 1, 0, or infinite. All right, now, I'm going to give you a couple practice questions to work on. So, graph each system of equations and write the coordinates of the points of intersection to the nearest tenth. So, grab Mr. Graphing Calculator, graph them, write out the answer. Now, honestly, it's pretty straightforward. I'm going to pause the recording. We'll compare answers. We'll come back and compare answers, okay? Now, notice I said you didn't have to write out the graph. I did because many of you playing around with your windows are screwed up. I don't mean screwed up, but Did you notice the second intersection point up here? At what was it, minus 4.5 and 15.6? Did you see that one? If it doesn't appear in your window, did Mr. Graphing Calculator find it? So what I mean is here, when you did your standard windows, did you see the second intersect? Second calculate intersect, enter. I'm scrolling over here, so I'm going here, enter, enter, enter. Now, this version of the graphing calculator will give me the calculation even if you can't see it on the window. Some versions of the TI don't. You have to see the intersect point on your window before it can do the calculations. All right? Mine can. Woohoo! So be careful. And that will be one of my 2 trick questions. Do you see the second intersect point on your window? All right, so guys, you understand that? So quickly, let's graph the second one, see what it looks like. Ratio. Okay, so the 2 equations like that, I got 0.5 and 5, and minus 2.5 and minus 2.1. If you got something different, go back and double check your equations. Usually this minus sign, we'll screw things up. Okay, so where was, oh yeah, sorry. Those are the coordinates I got. As I was saying, usually this minus, oh, what is your issue? Stop that, people are watching. That's the little negative sign, not the minus sign you put in front of the 2. That's usually where people screw up in this one. Or you put in a plus instead of a minus, because, I do that all the time. Now, my personal favorite trick question. How can I be nasty? Here it is. I give you the graphs, but not the equations. You have to figure out the equations. All right? So, I'll do one with you. Now this goes back to chapter 4. This is my P and Q value. This is 2, 1. That's P and Q. And then I have another point on this line. 1, 2, 3, 4. 4, 5. That's my X and Y value to find the equation of the parabola. And then I have a B value. And I have to find my slope. To find the equation of straight line. So this one I will do with you. Now I admit I'm doing this rather quickly. The quadratic. Okay. Y equals A times X minus 2 squared plus 1. Bringing back memories, nightmares, flashbacks? Good. Now, and then this becomes 5, 4, and solve for A. Actually, I should be color coding this just to be, sorry. Okay, that's where my 2 and 1 come from. Just a reminder, 4 minus 2 squared plus 1. Minus 1 from both sides, minus 1, so that is 4 equals A times minus 2 squared, or 4A, so A equals 1. Now, I really didn't give enough room here to write out the equation, but that is Y is equal to X minus 2 squared plus 1. That's my first equation. My other equation, Y equals MX plus B. Y is, well, my B value is 3. That's easy. What's my M value? Well, up 2 and over 1. That's 2 over 1, or Y equals 2X plus 3. So Y1, Y2. Graph them. What do I get? Well, you guys graph them. Take a moment, pause the recording, graph them. Come back and we'll check our solutions. Well, I got 0.3 and 3.7. And I got 5.6 and 14.3. Because there is a second solution up here. Yes, you have to be careful of that. Once again, sometimes some graphing calculators will tell you what the solution is, even if it can't see it. Now, I'm going to pause the recording, and I want you to do B. Notice it's going down, so it should be a negative A value. And then we'll come back and compare answers, okay? All right. So, my coordinates for my vertex P and Q are 2 and 1. So I got y equals a times x minus 2 squared plus 1. I have a value of 4 and minus 1, which gave me an a value of minus a half, which makes sense. So if you look at the vertex, I go over 1 and down, which looks like a half. I go over 2 and down 2 instead of 4, or half. So minus a half looks good. Then my b value is 2, and my m is down 6 and over 2, so minus 6 halves, or minus 3, which gives me the equation y equals minus 3x plus 2. Now, when I graph those two, I get two solutions, 0.6 and 0.1. Right there. And I get 9.4 and minus, what did I get? 26.1. And once again, you might have to change your windows. You find where these two intersect way the heck down here. Okay? So that's, yeah. That's pretty much it, except for the basic definition. What's the point of intersection of a linear quadratic system? Well, the solutions are numbers that work for both equations. Let's solve both equations. Okay, so that's it. This is graphing stuff. So go do the check your understanding. Give it a try. If you have trouble, shoot me an email. Otherwise, I'll see you next class. Thank you.